Hey YouTube, what's going on here? Alright, so we're gonna go through angle properties revision. You math lovers need to cope with two sort of problems. So the first, you have a complicated shape and you need to find, so using the properties for triangles or polygons. Okay, that's the first type of problem. And here you have also sort of parallel lines and you need to use the properties somehow. Alright. So let's get started. The first, what are you given here in the first question? So you're given that DF, it's here, equals to EF. All right, so two sides equal. I marked them. And actually, yes, you marked with two equal bars. So DF equals EF. You need to find the size of angle Z. So it's here, all right? It's here. Okay, so, or this is the angle DEF. Okay, so pay attention to the triangle because it's inside the triangle, and using this DF equals EF, we can figure out its isosceles. So we can say that triangle DFE is isosceles. So obviously two angles near the base should be equal, right? So that's why actually they're marked. So they're equal, FDE and angle FED. All right, so mark as Z. So two angles the same, so we can write 2Z, and if we add 110, we arrive to 180. So this is the property for angles of any triangle. It doesn't matter which triangle you have. In this case, isosceles, it will help you to have this fact that two angles the same. All right, so let's figure out quickly. So 2Z equals 70 from where Z is 35 degrees. Okay, so we found it. Let's go to the next question. Angle BCD. So BCD, all right, equals to the angle BAF. BAF. All right, so let's mark them as 2 equals angle. So I suppose that Y is good letter for it. Okay, so basically we need to find Y, okay? Find interior angle BCD, all right, BCD, exactly Y. Okay, so in this case, obviously you need to use the bigger shape. That is, let's count 1, 2, 3, 4, 5. So this is the pentagon. So clearly shows you that it's pentagon. So pentagon. All right, remember the properties about polygons, about interior angles, because it's all about angles, not sides. So you know that the sum, so I will use this notation, it's sigma notation, stays for the sum of all interior angles, I put I, so up to 5, right? Because in this case, from 1 to 5, we have 5 sides, 5 angles, and that will be equal to 5 minus 2 times 180. Just remember the property and the general formula for n minus 2 times 180. That stays for the sum of all interior angles, okay? So we plug 5 because 5 sides, and we know it's 540, right? Okay, so great. Now we know that the sum of angle is 540. What we can do, of course, so we will use this fact in order to sum them up and calculate the total amount. That is 540. All right, so let's come back here because we know that several angles we still don't know. Okay, let's mark this green. So let's mark angles that we don't know. We don't know this angle and 2y, of course. So let's do it quickly. We have an open angle, so 60 and some angle. If you add them up, you'll get 180. So supplementary angles, which values, if you add them up, will give you 180 degrees. All right, so the rest part is 120. And here 110 up to 180 is just basically you need to add 70 degrees. Okay, so we figure out all the angles, all internal angles except for 2y's. And now it's right time to complete equation about the sum of all interior angles. All right, so let's use the pentagon. And from here, we just need to say that 2y plus 120 plus, again, 120 and plus 70, all right? And plus 70. Hence, we'll have the result of 550. Sorry, 540. Okay, so from here, we obviously can solve because the only variable is here, so we just normally use as normal linear equation, all right? So 2y equals, let's calculate quick. So we need to subtract from 540 the rest part of all angles, all right? Let's do it. So 540 minus what we have, 240 and 70. Okay, so in total we have 230 degrees. For two angles, for each one we'll split by 2, and so we'll get the following 115 degrees. All right, so that's the final answer to the second question. All right, so we have y equals 115 degrees. We found all the angles, and that's actually interior angle for BCD. All right, so next one. So pay attention to what is here. Okay, so we have 3 parallel lines. So parallel means like little arrows that shows you 3 lines parallel. So question, find x, angle x, it's here. So CDB, okay? You're also given that 2 triangles, ABD and BCD, isosceles, okay? Let's check them up. You see the markers about the sides, okay? And here as well. All right, so 2 triangles are isosceles. Okay, so what we have, let's see. In order to find angle x, so the first question, so find x, and the second find reflex angle. Okay, so the first question, find x. Okay, so I would better consider triangle BCD. Okay, so in BCD, what we have? Oh, that's easy. We don't need to consider even a triangle. We have the second line, so CD is the second line for 2 parallel lines, line 1, line 2, line 3. So for lines 1 and 2, and hence angle x is actually 30 degrees. So we can figure out it quickly. Okay, so x is 30 degrees. All right, so you need to find reflex angle ABC. So I mark it with the blue. Okay, it's here. All right, so you need to find this angle. Okay, so how we can do that? Obviously, in this case, we need to use the fact that ABD and triangle BCD are isosceles. Okay, so obviously you know that the whole angle around, so I mean this angle around is 360, right? So if we find this angle and if we find angle here, so in total with our reflex angle will give us 360. Okay, let's try to use this fact. Okay, so question 2. So angle ABC, so ABC angle along with angle CBD and along with ABD will give us 360 degrees. Okay, so we know that angle X is 30 degrees and this triangle is isosceles, so having that triangle BCD isosceles, so we can state the fact that, let's say we marked this angle is y, so this angle also y, right? So we'll get the following equation for the sum of all three angles. So 2y plus angle x, in our case we found it, it's 30 degrees, okay, will give us 180. So we can figure out quickly for y, value for y, it's 150 over 2, 75 degrees. Okay, so we found that angle y, it means here and here, we found it's 75 degrees. Okay, let's move next. So angle, if we marked as z, so yeah, let's mark as z. What we can say that all right, yeah, I found it. So, and two other angles, so we don't know them, but however, have a look at again AD as the second line. So AD is the second line for lines 2 and 3, so I write this fact. So AD is second for lines 2 and 3. So 2 and 3, they're parallel lines. So looks like there's also 60 degrees, okay? So now, because triangle is isosceles, here is also 60 degrees. So what we can figure out? We can figure out that 60, 60, and z together will give us 180 degrees. So let's write this equation. So z plus 60 and 60 is 120, and the result is 180 degrees. So in this case, z is 60 degrees angle. Okay, cool. So it looks like this triangle is also an equilateral, right? So we know this angle also. So we know y and z together. So if we add angle, so if we use this equation, that gives us 360. So CBD is y. So CBD is y, it's here. And ABD, it's here. It's z, basically, that we found. So I just plug here and we can find ABC. So ABC plus 60 plus 75 will get 360 degrees. Okay, it's right time to find angle ABC. So angle ABC is 360 minus 135. Okay, that's an idea. Look, we apply like several rules. We consider like properties for triangles, for any triangles, for isosceles triangles, and we arrive to also the rule that we can arrange 360 degrees like as the sum of all angles. Okay, and we use also the properties for a second line. Okay, so ABC is 360 minus 135, so we'll get 360 minus 130, we'll get 230, and minus 5, 225 degrees, okay, in total. So that's angle ABC. All right, so reflex angle is 225. That was the revision for angle properties. We've done pretty a lot, and that's your practice. All right, thank you, and see you later.